Section 3.2, Graphing Rational Functions, Example 3. Graph the rational function h of x equals 2x squared minus 3x minus 5 all over x squared minus x minus 6. The first thing we need to do is factor both the numerator and the denominator, so let's do that. So I'm going to do a little fancy factor by grouping thing here, so we do 2 times negative 5 is negative 10. And then we want factors of negative 10 that will add up to negative 3. Oh, this is pretty basic because it's just the numbers we just had. So negative 5 and positive 2 multiply to get negative 10, but if we add them together, when they're x's, we will get negative 3x in the middle, right? So when we go to factor it, we would have 2x squared plus 2x minus 5x minus 5, and then take out 2x, so we have x plus 1, and then take out a negative 5, so we have x plus 1, and then put the factors together, so 2x minus 5 times x plus 1. Okay, so there's the numerator, and then the denominator is easier than that. X minus 3, x plus 2. Alright, that's step 1. Step 2, we revisit what they are really fast, find the domain, reduce X and Y intercepts. Okay, so finding the domain, we take the denominator, and we set it equal to 0. So x minus 3 equals 0, and x plus 2 equals 0. So that means x cannot equal 3 or negative 2. Then we reduce. Nothing reduces because none of these factors are the same as these factors. We can't cancel individual terms, like an x here and an x there or whatever. That doesn't work. So nothing reduces, so that means the vertical asymptotes are just at x equals 3 and x equals negative 2. I'll put those in my picture. Alrighty. Now we're going to find x and y intercepts. Alright, so to find x-intercepts, we take our numerator and we set it equal to 0. I think it's easier if we just do our factors that we already just found and set those equal to 0, right? Alright, oops, that's not what I meant to do. Go back, there we go. Ta-da. So this one equal to 0 is going to be 2x equals 5, so x equals 5 halves, or 2.5. And then the other one is x plus 1 equals 0, so x equals negative 1. So let's put an x-intercept, sorry, at negative 1 and at positive 2.5. Okay, now let's find y-intercepts. So, actually there could only be one or none, that wasn't quite right. So if I plug in 0 times 2 squared is 0, and then 3 times 0 is 0, and negative 5, and then 0 squared minus 0 minus 6, so that puts a y-intercept at 5/6. So that would be about right here. Now we need to plug in some other points. So let's do some x's that are less than one asymptote and more than the other one. Oh, we forgot to do the horizontal asymptote. Okay, my brain's on this one right now, so I'm going to keep going. So I'm going to do negative 3, and I'm going to do positive 4, So -3, what step should I plug it into? Maybe this one right here. So -3 times 2 is -6, minus 5 is -11, and that will be times -3 plus 1 is -2, so that's a positive number. And then we're going to divide by -3 minus 3, which is -6, and -3 plus 2, which is -1. Okay, so that gives us 22/6, or 11/3. So that's like 3 2/3 or something like that. So at -3 we have 3 2/3-ish. Perfect. Then we're going to plug in 4. So 4 times 2 is 8, minus 5 is 3, 4 plus 1 is 5, and then 4 minus 3 is 1, and 4 plus 2 is 6. So that gives us 15/6. 6 goes into that twice with 3 left over. So that would be 3/6. I'll just do 2 1/2. So at 4 we're at 2 1/2. So that right there. Okay. Let's go back to horizontal asymptote, which I skipped for some reason. So the horizontal asymptote is where we have degrees equal to each other. So degree 2 divided by degree 2. So just a note, degrees are equal. So the leading coefficients are 2/1. So that means y equals 2. So we have a horizontal asymptote here at 2. Okay, if you want, you can plug in some more points, but I think we're good. So I'm just going to sketch and work with what we have here. We'll have a branch over in this section here. We'll have a branch here. We'll have a little upside down thing happening here. And let's see if the graph from technology agrees. Looks about right. And notice how none of the factors have any multiplicities, so none of the int behaviors are going the same way, and none of the x-intercepts are touching the x-axis. They all cross it.